Light bulbs as we know them have largely been unchanged for the last 90 years. In fact, look at this package of GE light bulbs from 1936. It looks pretty much the same as it would today. By 2014, this will change. New energy regulations will phase out our old existing incandescent light bulbs and usher in a new era with new energy-efficient bulbs. So this is a story about where the old incandescent bulb came from and one of the neatest things you can do with an old bulb. We all know Thomas Edison as the inventor of the light bulb, but he was actually the inventor of the first commercially viable bulb. There were many other bulbs before his. The biggest problem with a commercially viable light bulb was to have a filament that would not burn out. Edison actually tried over 5,000 different varieties of material to produce his light bulb. This is the actual light bulb that Edison used in the first public display of his new electric light. It now resides in the Smithsonian. There are some of Edison's bulbs still in existence today, and in fact, some of them are still operational. As of 2011, there is one bulb that is still burning that was said to be turned on in 1902. This is the bulb. It's at the Edison Museum in New Jersey. The choice of filament in Edison's bulbs was carbon fiber made from bamboo. Somehow the carbon that came from the bamboo was stronger and more heat resistant than other forms of carbon. It had been known for many years that removing the air containing oxygen from inside the bulb made the filament last much longer. The better the vacuum pump, the better the bulb. Edison's lab was filled with some of the finest analytical and research equipment of his day. His choice of a high-power vacuum pump was one of the things that made his light bulb commercially successful. One of the problems with the original Edison bulbs was that over time the inside of the glass bulb would begin to darken with a bit of carbon soot. This problem was fixed in 1906 with the switch from carbon to the metal tungsten as a choice for filament. The metal tungsten is not only easy to draw onto a wire, not too expensive, and fairly easy to mine, but it is extremely resistant to high temperatures. All members of this family on the periodic table are very heat resistant and have extremely high melting points. This makes them a perfect choice for filaments. When an electric current is passed through the thin tungsten filament, the wire will begin to glow at around 3,000 degrees Celsius, first yellow and then with a nice white light. But that heat is part of the problem. Only about 2.6% of the energy put into the light bulb is converted to light. The rest is lost as heat, and if you're not trying to heat something up with that bulb, you're wasting that energy. The new LED and compact fluorescent bulbs actually are more energy efficient, primarily due to the fact that they don't convert much of their energy to heat. Therefore, they are much more energy efficient. Any filament, when heated, will begin to react with oxygen in the air. The resulting metal oxide is extremely brittle and will break very easily. During manufacture, the air and the oxygen are pumped out of the glass spheres, and once the air is removed, an unreactive gas is pumped in. Some of the gases used are argon, neon, or most often nitrogen. With an inert gas inside, the pressure inside the bulb will match the outside pressure, which will reduce the chance of breakage. So this is a filament out of a standard 100-watt light bulb. We've taken the bulb off without damaging the filament. If we plugged in this filament right now, it would last about 2.5 seconds. But now the fun part comes. What if we could surround this filament with something that would keep the oxygen away, but yet still let the filament get hot enough to glow.